Okay, let us discuss the next problem, problem number 13. And that problem is, a shell is fired from a cannon with a velocity v at an angle theta with the horizontal. At the highest point of its path, it explodes into two pieces of equal mass. One of the pieces retraced the path to the cannon, the speed of the other piece immediately after explosion. This is a problem of projectile and conservation of linear momentum. Let us see, when a shell is fired, it can be taken as a projectile. The projectile means it traces a parabolic path. Therefore, let us take the diagram xy planes, and from here say a shell is fired with a velocity v, as it is given, velocity is v at an angle theta. Then we know it traces a parabolic path and reaches to the ground, and this is the highest point of the path. And here what was happened, it was exploded into two pieces. As we know, in a parabolic path, at highest point the velocity will be u cos theta, or here if it is fired with a velocity u, but here it is fired with a velocity v, therefore it can be taken as v cos theta. Let us say it is u. If you can resolve this into two components, one as u cos theta and one as u sin theta, but in the horizontal direction we know velocity remains constant, so the velocity will be v cos theta by the time it reaches to the highest point. But there it exploded into two pieces. Suppose here the mass of the piece, say m, that cannon, by the time it comes here, it has exploded into two pieces. Say the mass of this one is m by 2, the mass of this one is m by 2, it was exploded into two pieces of equal mass. So m by 2, m by 2. But one piece retraced the path to the cannon. This piece has again come back to the same. If it has to come back, its velocity is directed in this direction. And from here, if it has to come back to the cannon, its velocity should be u cos theta, because by the time it reaches its velocity is u cos theta. So it has to come back means its velocity should remain as what? U cos theta only. Therefore, now at highest point, we have to apply law of conservation of linear momentum. Conservation of linear momentum. Then total momentum before collision is equal to total momentum after collision, and total momentum before collision, it is only one piece before collision, so its mass is m, but it is exploding into two pieces at the highest point. At the highest point, the combined mass will have a velocity u cos theta. But after here, collision means you can take explosion. So total momentum before explosion you can take, and total momentum after explosion. Before explosion it is only one piece of velocity u cos theta, but after explosion it has become two pieces. One piece is of mass m by 2, and what is its velocity? As it is retracing to cannon, its velocity is u cos theta, but it is opposite to the direction of initial velocity. So we have to take the negative sign. So it is minus u cos theta plus second piece is m by 2. We have to find out its velocity. Say that velocity as v prime. And here u means v. Therefore this I can write mv cos theta minus m by 2 v cos theta plus m by 2 v prime. As v prime is the velocity of the second piece, and that velocity to calculate, simplify. Here mv cos theta plus m by 2 v cos theta is equal to m by 2 v prime. This if you bring it to side, it becomes plus. Then mv cos theta plus m by 2 cos theta, if you simplify, 3mv cos theta by 2 is equal to m by 2 v prime. So m by 2, m by 2, m by 2, m by 2 cancels. So v prime you are going to get 3v cos theta. Therefore, the velocity of the second piece will be 3v cos theta. So in the options, first option is 3v cos theta. So first option is the correct answer. Now let us see the next problem, that is problem number 14. See what is that problem. The particle collides from a similar particle at rest with a speed v. If second particle moves with a velocity v1, in direction perpendicular to initial velocity of the first particle, then calculate the speed of the first particle after collision. So let us see this problem. See, a particle is colliding from similar particle at rest, and that particle is moving with a speed v. Suppose say there is a particle here, mass m, moving with a velocity v. It is colliding with another particle of mass, similar particle, say mass m, which is at rest, and its velocity we can take u2 is equal to 0. Say this is the particle of mass m. Now it is colliding with another particle of mass m, which is at rest. Therefore, let us take its velocity, second particle u2 0. First particle, as it is giving, it is moving with a speed v. Therefore, here u1 is equal to v we can take. This is the situation before collision. But what is happening after collision? After collision, second particle moves with a velocity v1. Say this is the first particle and this is the second particle. Second particle is moving with a velocity v1 in the direction perpendicular to initial velocity of the first particle. This is initial velocity of the first particle. This is the direction of initial velocity of the first particle. Second particle is moving perpendicular to this v1. This is the second particle moving in this direction. Then we have to calculate the velocity of the first particle. After collision, the velocity of the first particle, let us take it as v prime, and v prime is how much, that we have to calculate. This is the situation before collision. After collision, let us take the situation. Say first particle is moving in the same direction, but it is given second particle is moving in a direction perpendicular to the first particle. So second particle is moving in this direction at right angles to the first particle direction. Then we want to calculate the speed of the first particle after collision. So now apply law of conservation of linear momentum. Apply law of conservation of linear momentum. If you apply this law, total momentum before collision, we can write total momentum after collision. Before collision, only this particle is moving. So its momentum is mv plus the momentum of the second particle is 0. After collision, these two particles are moving in perpendicular directions. So what will be the total momentum? As they are moving in perpendicular directions, the total momentum will become root of mv1 square plus mv square, mv prime square. As the momentum of the first particle is mv prime, momentum of the second particle is mv1. As they are moving in mutually perpendicular directions, you have to apply parallelogram law. Then the total momentum will be under root m1 v1 square plus mv prime square. Now, if you simplify this, to simplify both sides, if you square, you get m square v square is equal to m square v1 square plus m square v prime square you are going to get. But in this, we have to calculate the velocity of calculate the speed of the first particle v1. So m square both sides gets cancelled. So v square is equal to v1 square plus v prime square. So v square minus v1 square is v prime square. So v prime we want. So the v prime will become under root v square minus v1 square. This is the velocity of the first particle after collision. In the options, third option is v square plus v1 square. So here if you simplify, v square minus v1 square is v prime square, where v prime is velocity of the first particle after collision. Now if you want to calculate this v prime square, let us take square root. V prime is under root v square minus v1 square. So this will be the velocity of the first particle after collision. In the options, let us see, fourth option is root of v square minus v1 square. So fourth option is the correct answer. So now let us see the next problem, problem number 15. It is given the following figure: a uniform rod of length 30 cm having mass 3 kg. It is pulled by two strings on both sides as given in the diagram, one with 20 Newton and the other with 30 Newton. Then find the force exerted by 20 cm part of the rod on 10 cm part, and moreover given it is all the surfaces are smooth and the strings are light. Now let us see how to solve this problem. See, this is a rod, and this rod is of 30 cm length, but here this was shown as 20 cm part, this was shown as 10 cm part, and here it is acting a force of 32 Newton, here it is a force of 20 Newton is acting. Now we want to calculate force exerted by 20 cm part on 10 cm part. What is the force exerted? This we have to calculate in the problem. To solve this problem, see here on this rod there are two forces acting, on one side 32 and other side 20 Newton, both are acting in opposite direction. Then this force is of greater magnitude, this force is of smaller magnitude. So overall the body will move in this direction of greater magnitude force, and find out the net force. And the net force acting will be, as both are acting in opposite direction, the net force will be 32 minus 20. 32 minus 20 will be 12 Newtons. And this 12 Newtons force is acting on a body of mass 3 kilogram. As it is given, the rod is of mass 3 kilogram. Therefore, what is the acceleration? When net force is acting, this net force causes an acceleration in the body in this direction, in the direction of net force. Let us calculate the acceleration. Acceleration is net force by mass. From Newton's second law you can write. So net force is 12 Newtons and mass is 3. So it will be 4 meter per second square. These two forces together cause an acceleration of 4 meter per second square in this body in this direction, in the direction of net force, force of greater magnitude. Now, when this force is acting on the entire rod, every part of the rod also moves with what acceleration? Same acceleration. Now, here we have to calculate the force exerted by 20 cm part on 10 cm part. Both parts are of the same rod, therefore they move with the same acceleration. That point if you remember. Now, what I do is, to calculate this force, I divide this rod into two parts. One part is of length 10 cm, another part is of length 20 cm. Let us divide, and I assume these two are connected by a light string. This is a light string, an ideal string, because when it is assumed that it is a light string, an ideal string, tension will be same everywhere. So wherever you want to find the force, let us divide the body there into two parts. Let us assume both are connected by a light string. Then the mass of this part will be, as it is given, 30 centimeters has mass 3 kilogram. 10 centimeters, from this we can write 1 kilogram. 20 centimeters will have a mass of what? 2 kilogram. From that data we can write, then this will have a mass of 1 kilogram. This part will have a mass of 2 kilogram. Total mass is what? 3 kilogram. Then here if you write the forces, here a 20 Newton force is acting, already given. Here a 32 Newton force is acting, already given, and moreover both are moving in this direction with an acceleration of 4 meter per second square. Now when these two are connected by a light inextensible string, as you apply a force is exerted by this on this, and similarly a force is exerted by this on this, and that force, if you take it as F, there is a tension as both were pulled, and finally the body is moving in this direction. A tension will develop. The tension we will take it as what? Force, and that force if you calculate. So here let us assume these two are connected by a light string. Therefore, as they are moving with an acceleration a force will develop in this light string. It is same throughout the string, and that force if you denote like this. Now we have to calculate this force. To find out this force, let us draw free body diagram for M1. If you take this part, what are the forces that are acting? This is M1. Here already given a force 20 Newton is acting, and another force is acting on the body F, but it is moving in this direction with an acceleration A. Now these two forces are acting in opposite direction, but it is moving in this direction. Therefore, net force I can write F minus 20 Newton. I can write, because as it is moving in this direction, this force must be greater than this force. Therefore, F minus 20. Net force I can write M1A is F minus 20. And what is M1? The mass of this body is 1. And what is acceleration? 4. is equal to F minus 20. Therefore, 4 plus 20 is equal to F. That means the force F is equal to 24 newtons you are going to get. This is the force exerted by 20 cm part on 10 cm part. This is the force. This is the force that is present between these two parts, and that force we got it as 24 Newton. If you see the options, fourth option is 24 Newton. So, fourth option is the correct answer. Let us see the next problem, that is problem number 16. The problem is a block is kept on a smooth inclined plane of angle of inclination 30 degrees that moves with constant acceleration so that the block does not slide relative to the inclined plane. F1 is the contact force between the block and the plane. Now the inclined plane stops. F2 is the contact force given. What is the ratio of F1 by F2? That is the problem. So let us solve the problem. First let us take an inclined plane. This is the inclined plane. This angle of inclination of the inclined plane was given, say some theta 30 degrees, and a block is there on the inclined plane. Suppose say this is the block that is kept on the inclined plane. When this is the block, what are the forces that are acting on the block that we have to see? Here both are moving with an acceleration. It is not sliding, and it is given the block does not slide relative to the inclined plane, and it is moving with a constant acceleration. That means here the weight of the block acts vertically downwards. This you have to remember. And as the block presses the inclined plane down, the inclined plane will exert a force on the block in this direction, that is the contact force. That force F1 is given in the problem. Now this F1 we have to calculate here. If you calculate as both together are moving with an acceleration A, the block is not sliding. If you resolve this F1 into two components, as this angle is theta, we can show that this angle also theta. Then if you resolve, this will be F1 cos theta, this will be F1 sin theta if you resolve. Then if you balance the forces here, F1 sin theta will be ma, because it is moving with a constant acceleration, it can be taken as ma, and F1 cos theta is equal to mg, it is balancing mg. This is the situation in the first case. Now in this case both are moving with an acceleration a, but in the second case it is given the inclined plane stops. That means it is not moving with an acceleration. If it is stops, like this inclined plane has stopped, then the block starts sliding down. Here both are moving with an acceleration, block is not sliding, but the inclined plane stops. When it stops, angle remains the same, angle theta is equal to 30 degrees. Now what are the forces that are acting? Normal force will act like this. That normal force in the diagram was given as what? F2. Then its weight acts vertically downwards. This is the weight that is acting mg. Then which provides the normal force? If this angle is theta, we can show that this angle as theta. If you resolve this mg into two components, this will be mg cos theta and this will be mg sin theta you are going to get. So when it stops, the normal force is provided by mg cos theta here in the second case. But in the problem we want the ratio of F1 by F2. F1 by F2 if you want to calculate, from the first case we can write F1 cos theta is equal to mg. In the second case we can write F2 is equal to mg cos theta. As we have to eliminate mg because mass is not given, divide these two. If you divide these two, you will get F1 cos theta by F2 is equal to mg gets cancelled, 1 by cos theta you will get. So you will get F1 by F2 is equal to 1 by cos square theta you are going to get. Then what is its value? F1 by F2 is 1 by cos square 30. As here the angle was given as 30. So cos 30 is root 3 by 2 whole square. If you simplify, it will be 4 by 3. So the ratio of forces F1 by F2 will be 4 by 3. If you see the options, second option is 4 by 3, hence answer is 2. Now let us see the next problem, problem number 17. See that problem. the problem was given as a smooth sphere of mass m is moving on a horizontal plane with a velocity 3I plus j. It collides with a vertical wall which is parallel to the vector j cap. E was given half. Then the impulse that acts on the sphere. This problem we can do like this. Let us take x and y axis like this. This is x axis and this is y axis. Here the wall is along the vector j. J cap is the unit vector along y axis. So I draw the diagram like this. This is the wall. Wall is along y axis, and here a ball is moving in the horizontal plane with a velocity 3I plus j. 3I plus j means that ball we can show moving in this direction. This is the ball, its velocity is given 3I plus j. 3I plus j means ball is moving in this direction, but the wall is there, it is striking with the wall. So its velocity is 3 along x axis and 1 along y axis, because it is 3I plus j. Like this, 3 meters per second you can take the velocity, and this is 1 meters per second. This is before collision. And before collision, the velocity I write u bar. A u bar is given as 3I plus j. Then you want to calculate velocity after collision, because impulse you have to calculate as impulse imparted. If you want to calculate, impulse is equal to mv bar minus u bar, change in momentum. Impulse is nothing but delta p bar. Delta p bar is what? Change in momentum. Change in momentum is m into v bar minus u bar. So to calculate this, we require v bar. If you know v bar, you can calculate the impulse imparted. So what is its velocity after collision? As it is moving in this direction, it collides with the wall and it reflects like this. The ball gets reflected. When the ball gets reflected, what is its? This is after collision. Again, it has velocities in this direction and in this direction. These are the components of velocity. To calculate this velocity, for this diagram, this becomes a Cn, common normal, perpendicular to the wall, common normal. As coefficient of restitution is given along common normal, coefficient of restitution I can write v2 minus v1 by u1 minus u2. This is the formula for coefficient of restitution. But here, this is the wall. Before collision and after collision, wall will be at rest. So I can take its velocity u2 0 before collision, v2 0 after collision. So u2 and v2 will be 0. Therefore, if you find E value was given half, what is v2? v2 is 0 minus, we have to calculate v1. So minus v1 after collision by u1. u1 is 3. Before collision, the velocity along common normal direction is 3 and u2 is 0. Therefore, if you calculate this, minus v1 by 3 you are going to get, or v1 is equal to minus 3 by 2 you are going to get. This is the velocity along x axis. With this, how do you write the velocity of the ball after collision? V bar is equal to x component. This component you are going to get minus 3 by 2 meter per second. As before collision it is moving towards the wall, after collision it is moving away from the wall. Minus indicates it is moving away from the wall. Therefore, its velocity I can write x component plus y component minus 3 by 2 I cap plus y component remains the same. So it will be j cap only, meters per second. And this is the initial velocity, meters per second. So only x component of velocity is getting reversed, but y component remains the same. This value can be obtained by using the value of E, coefficient of restitution, as it is given. Therefore, what is the impulse? Impulse is equal to m into v bar minus u bar. V bar is minus 3 by 2 I cap plus j cap minus u bar is 3I plus j. So this, if you simplify m, minus 3 by 2 I cap plus j cap minus 3I minus j. So plus j minus j gets cancelled. Therefore, the impulse j bar. So j bar is equal to m into minus 3 by 2 I cap plus j minus 3I minus j. J and j gets cancelled. Then this further simplify. J bar is equal to m minus 3 by 2 I cap minus 3 I cap. M 3 to 6 minus 3 minus 9 by 2 I cap. If you further simplify, minus 9m by 2 I cap. If you simplify, you are going to get minus 9 by 2m I cap. So that will be the impulse imparted by the sphere on the wall. If you see the options, first option minus 9 by 2m I cap is the correct answer. So answer is 1. Now let us see the next problem, that is problem number 18. And the problem is a particle of mass 2m is projected at an angle of 45 degrees with the horizontal with a velocity 20 root 2 meter per second. After 1 second, explosion takes place and the particle is broken into 2 equal pieces. As a result of explosion, one part comes to rest. The maximum height attained from the ground by the other part is g value was given. Let us see how to solve the problem. Here also a particle is projected at an angle. So it is a projectile, the path is a parabola, that you have to understood. Let us see here. From here, a particle of mass 2m was given, projected with a velocity. That velocity u is 20 root 2 meter per second at an angle of theta is equal to 45 degrees. Then it traces a parabolic path like this and strikes the ground somewhere here. Now, during its path, after 1 second, explosion has taken place. Let us see where is it after 1 second. Is it at maximum height or somewhere else? Let us calculate the time of ascent. Time of ascent is u sin theta by g. U sin theta, u is 20 root 2, sin 45 by g is 10. And at 20 root 2, sin 45 is 1 by root 2 by 10. Root 2 gets cancelled. So time of ascent to 2 seconds you are going to get. That means it takes 2 seconds to reach to the maximum height. But here it is given 1 second. 1 second is less than 2 seconds. Therefore, definitely it is not at the maximum height. Somewhere here it is. After 1 second, this mass is somewhere here. When it reaches here, explosion has taken place. And when it reaches here, what is its velocity? Velocity will be along the tangent drawn at that point. And this is the velocity. And that velocity you have to calculate. And here you have to apply law of conservation of linear momentum. So let us calculate this velocity. If you resolve this velocity into 2 components, this direction is u cos theta. This direction is u sin theta. This is 20 root 2 cos 45. 20 root 2 into cos 45 is 1 by root 2. It will be 20 meter per second. Here also it is 20 root 2 sin 45. So 20 root 2 into sin 45 is 1 by root 2. This component also will become 20 meter per second. As you know, the horizontal component of velocity remains the same. Ux is 20 only, but this is the vertical component of velocity. This vertical component of here, horizontal component Vx and Ux will be same. Vertical component of velocity Vy will change. So that Vy you have to calculate. So along y-axis, how do you calculate the vertical component of velocity? Let us take v is equal to u plus at, as you know the formula, because time you know. V is Vy, the velocity in the beginning in the vertical direction is 20, as it is going up, a can be taken as what? Minus g, because against gravity. So a value was given, g was given as 10 after 1 second. So this velocity will be 20 minus 10. So Vy will 20 minus 10 is what? 10 meters per second. So along y-axis, if you calculate after 1 second, the vertical component of velocity is becoming 10 meters per second. Horizontal component remains constant. So at this point of time, what is happening? that piece is breaking into two equal masses and one part is coming into rest. So, other part is still in motion. So, we have to calculate the velocity of the second part. For that purpose, apply law of conservation of linear momentum. If you apply law of conservation of linear momentum, total momentum before explosion. Before explosion, it is a single piece, so 2m. And what is its velocity along y-axis? Before explosion, the velocity along y-axis we got 10 is equal to, after explosion it is breaking into two pieces. Total mass is 2m. Two equal pieces means one piece is of mass m, but it is given one piece is coming into rest. So, into 0 plus the other piece velocity we have to calculate. That velocity you take it as v prime. So, if you simplify this, 2 into 10, 20m is equal to mv prime you are going to get. So, m and m gets cancelled. So, the second piece velocity will become 20 meters per second. So, here first piece is coming into rest. By the time it reaches, explosion takes place, first piece coming into rest means it falls down. But second piece has a velocity of 20 meters per second. So, second piece from here becomes a body projected vertically upwards. Therefore, what is the maximum height attained by second piece? Let us calculate. Maximum height attained by second piece. For maximum height, you know the formula u square by 2g. So, here, but velocity is v prime square by 2g, I can write v prime square by 2g. V prime was given 20, so 20 into 20 by 2 into g is 10. If you simplify, so the maximum height attained is 20 meter you are going to get. But in the problem, maximum height attained from the ground you want with respect to the ground. That means second piece from here it is going to some height of 20 meter, but it is already at a height, that height we have taken it as h. So, we have to calculate that height. So, to calculate that height, but we want from the ground. If you use ut plus half at square, h is equal to, we want to calculate this height. Here I projected the body, it is reaching to this point in a time of t 1 second. In the beginning, I projected the body with a velocity 20, therefore, u is 20. After 1 second, I want minus half, because a is equal to minus g, 10 into t square is 1 square. If you take this as 20 minus 5, that means 15 meter you are going to get. So, explosion has taken place at a height of 15 meter, and here second piece is going to a height of 20 meter. Therefore, what is the total height from the ground? The total height from the ground, if you calculate, therefore, height from the ground is equal to, it is already at a height 15 plus with velocity it is going to a height of 20. Therefore, total height you are going to get 35 meter. So, in the options, you have the fourth option as 35 meter. So, from the ground, the height of the other part will be 35 meters. Fourth option is the correct answer.